Now, we have this equation. 3y dx plus x dy equal to 0. I just want to know whether this equation is an exact equation or not. What you get for derivative of m to y? 3. Derivative of n to x? 1. Equal or not equal? So it's not exact. But I said I'll multiply this equation with x squared. I'll take the x squared times to this equation. I would get 3x squared y dx plus x to the power 3 dy equal to 0. Right? Right? Because at the beginning I have this equation. And then I check it whether it's exact. Okay, the result end up with it's not exact equation. And then I said, then what if I time this equation with x squared? Okay, so I just put x squared there. And then I'll check it again whether it isn't exact or not. M is equal to 3x squared y and n is equal to x to the power 3. So derivative of m by y is equal to what? Huh? Derivative of m to y equal to, I heard you guys try to say something to me, but you've got to make it loud. 3x squared, right? Is it the same? Okay. Now, derivative of m to the x. Equal? Now it's turning to the exact equation. So any function that you put into the equation which is not exact equation, after you multiply it in there in that equation, then it's turning that equation from not exact become an exact. That type of function we call integrating factor. So I said, okay, then we call x squared as an integrating factor. So, like, because you learn the way to solve the differential equation, many ways that you already learned. And I'm not sure whether you feel the same way as mine, that the exact equation is the simplest one that you can find a solution. You just check whether it is an exact equation or not, and then the way that you find, you can integral with respect to any variable by keeping another variable constant. That is the simplest one ever. So if we can change the non-exact equation to be an exact equation, then we can find the solution of that differential equation easily. That's the whole idea. Only that you know what would be the integrating factor for that equation, right? And then they have the way to find the integrating factor. This is the definition. If you have the equation like m dx plus n dy equal to 0, and then you know that it is not exact equation, So that means when you do derivative of m by y is not equal to derivative of n by x. Okay? But when you take mu, multiply to this equation, and then the new one that you times mu, you see mu, right? Mu x, y there. And now this equation becoming an exact equation. The mu function, we call it integrating factor. So the meaning of integrating factor is any function that when you multiply to your not exact differential equation, and it just make your differential equation become exact equation, that function we call integrating factor. And of course, we have the way to find integrating factor. I am just writing into 4 cases. Okay, the first one, if you have m dx and m dy equal to 0, and this equation is not exact equation, but we have 1 over n times the difference between the derivative of m by y and derivative of n by x become a function of x only, then the way that you can find the integrating factor is by using this formula. But if you do this and it is not a function of x only, you have x and y together, don't give up. You can go on to the second case, that 1 over m times the differences between the derivative of x and derivative of m by y. If it is a gy, it is a function of y only, you can find the integrating factor by using this formula, equal to the exponential of integral gy dy. When you do it, you can start from the first case first. If the first case you find this term as a function of x only, your integrating factor is finding from this formula. You don't need to go to the second case. You don't need to go to the second case. If the first case works, don't go to the second, third, or fourth. Just pick the first one right away. But if the first one won't work, take the second one. And if the second one won't work, take the third and the fourth. But if still cannot, so that means go to other techniques. This technique won't work any longer. Okay? So all cases, like 1, 2, 3, 4 cases, they are in your textbook. Okay? You can find the details there.